How's it going, Christian?
I'm doing good, Professor.
Glad to hear it. Anybody have any questions on any specifics? I have decided what I'm going to do about the exam. So, I've got those 3 versions of the practice test. I took down one of them. There's a respondus practice test. I'm probably going to put the other one back up there. It'll say Proctor respondus practice test. And then there's a respondus practice test. The Proctor respondus test, practice test, is for if something comes up at the last moment and you realize, oh crap, I can't go into lab tonight. Ideally, what you're going to want to do is still take the test at the same time, so I don't have to make another one. And what you'll do is quickly take the practice or the Proctor respondus practice test, so you can make sure your camera works and that sort of setup. Once you're done with that, then you can go to lab, then you can go ahead and take the test right at 7:10, I think is what time your lab's supposed to start. Other than that, everybody can just take it in the lab. If you have a laptop that you don't mind taking with you, that 1 runs the internet on campus, 2 can run Canvas, and 3 can actually run Canvas tests and display all the images and the special characters and all that. If you've got an iPad or a Kindle or a laptop that does that and you don't mind bringing it, go ahead and bring it. If you don't, we have 8 computers in there, and normally that should be enough. Actually, our class is so small, each of you could have a computer, be fine. But you're going to still do the respondus lockdown browser, so you still got to take the respondus practice test no matter what. It's just Miss Rashkovic. Sorry, I'm horribly mispronouncing her name. She said she could administer the test during her lab. So I think your lab's on Tuesday, right?
Yes, mine.
Yeah, so you can go ahead and I think everybody's in this class is, so you can go ahead and take it at that lab time. What I will do is I'll log in at 5:20, just in case anybody has any last minute questions. Some people don't like to attend such a thing just before a test. It makes them nervous. So it's not that you're required to be there. I'm not going to take roll or anything like that. I'm just going to be there. And if nobody shows up for the first 10 minutes, and I'll just go ahead and split. Other than that, you guys can just show up at lab time and take your test at that time. So your test is Tuesday at lab time. I think she gets there usually by around 6:50 or something. So if you want to take it a little earlier, you might be able to start a little earlier, but I can't be sure about that. You need to ask her. But she's definitely going to be there at class time, and she did say she didn't mind offering up the lab time for it. So everybody follow what we're doing now with regards to that? All of you too?
Yeah, I'm good. We're taking it in the lab on Tuesday, right? That's it?
Yeah, that's it. And you'll have the respondus lockdown browser just so you can't do any web searches that she might miss. But she'll be still walking around and watching, so you don't want to have your phone out or any of that kind of stuff. If you, for instance, sometimes I get people that are enlisted or whatever and they have duty. If you're in that situation, make sure you let her know beforehand and ask her what you can do with the phone. She might let you sit it right there. She might make you just leave it up at the desk, and then you come check it as you need, or something like that. So we're not trying to make any problems with that. I just don't want you to have access to the internet. You would not believe how many students I've had try to cheat. I catch them literally on their phone with their notes open. I've catch them on their phone with their Chegg. I've caught them on my iPad with Chegg. I've had them find stuff written down on pages that are all stuffed in their pants legs, all sorts of stuff. So we're just trying not to let any of that happen. You are allowed an equation sheet, don't forget. And the equations that you're allowed are only the ones that are numbered in the book, plus the special ones that I gave you, like that special formula for for Coulomb's law, where I had the vector RP minus RS and all that stuff. That you're of course allowed. And in the case of abuse of art, which you're not going to be tested on this time, but that will be allowed on the final. I don't think you're tested on. Actually, no, you might be. I think, yeah, abuse of art might be part of this exam because it goes up to chapter 28. So that abuse of art version that I gave you, that's acceptable too. You can put any constants on there you want. You can put any conversion factors. You can even say, V is velocity, or, put a name by each of the variables you're using for any equation. I don't mind you having integrals on there or derivatives on there. I don't have a limit to the number of pages of equations, constants, and stuff like that you have. You can't have a bunch of string of equations that line up to make an example from the book or something like that. So when you go to take it, you're going to have to actually show Mr. Eskovic your equation sheet and show it at the respondus thing. So actually, no, you want to show it at the respondus thing. You'll just check it with Mr. Eskovic. So any questions on anything there? All right, so this one is being recorded. Last night I had a boo-boo and ended up not recording it. So this one is being recorded. So those of you who came in, that the person that came in just now, you can catch what I just said. Now I'm just going to take questions on any material that we've covered that you might want help with regards to the midterm practice test that you've been taking, or any other past test questions, because that's pretty much what the midterm's about. So we got another person. So no one has any questions? Okay,
I'm being honest. I got a statics test today. I've been doing statics all week. I start your stuff tomorrow.
Gotcha. Well, let me advise you this then. Okay. So this is the second semester electricity and magnetism portion of the 242 class. It's calculus based. There's sort of some fundamental things that everybody has to be able to show that they can do. Like in the first semester, one of the key things in the 241 class was definitely you got to be able to resolve and add vectors and take cross products and dot products and stuff like that. In this semester, though, it's a little bit more steep. And actually, that last semester, I would normally make sure students can use integrals to calculate center of mass, use integrals to calculate moment of inertia, a few other things like that. But in this class, and use integrals to do work. In this class, the first thing you got to be able to do is you got to be able to use Coulomb's law in integral form, or Gauss's law, or I should say, and Gauss's law, to calculate the electric field of some charge distribution. You just got to be able to do that. You've seen the examples I've done in class, but that's basically it. Not only that, you got to then be able to take that electric field and use it to calculate the voltage between two parts using V equals a negative integral of E dot dl. That gives you a voltage difference, like between two parallel plates, or between a coaxial center wire and a coaxial cylindrical shell that's charged, or between two spherical shells. Even all of those are fair game. You calculate the voltage between those two, and then you use C equals Q over V to determine the capacitance. Okay, that's sort of a whole system, a whole process that you have to go through that covers a lot of chapters, and it's sort of what I call like a capstone problem. If you can do that, then you've got 3 or 4 chapters that I feel you've mastered to some extent. You still have the easy questions like resolve an equivalent resistance, and when all of them are in series, or when all of them are in parallel, or when some in series and some in parallel. Same thing with capacitors, but those are supposed to be quote unquote chucker questions. So that big paradigm of using something to find the electric field, whether it be Coulomb's law or Gauss's law, then using V equals negative integral of E dot dl to find the voltage difference between two spots, and then use C equals Q over V to find the capacitance. That's one type of problem you got to be able to solve. Another one is using Ampere's law. So you've got to be able to use Ampere's law to calculate a magnetic field, or you got to use the law of Biot-Savart to calculate a magnetic field. Biot-Savart obviously is a much more complicated one, and there's very few symmetries we can do. But for instance, those lines where it's got radial current coming towards the origin, and then it makes a quarter circle or a half circle, or maybe a 2/3 circle or something like that, and then it goes radially again, and so on and so forth. You got to be able to use Biot-Savart for that. You don't have to show too much of the calculus on that if you figured out the pattern, but that's definitely something you got to do. But the more likely thing is use Ampere's law to find the magnetic field around a infinitely long straight current carrying wire, or around a infinitely long straight current carrying inner wire with a cylindrical outer wire carrying current in the opposite direction. So find that electric field between those two. That's a coaxial cable. Or find the electric field, say in a solenoid, or find the electric field at say in a toroid. So all that you should be able to do. Then you should be able to use flux is equal to the integral of B dot dA to calculate the magnetic flux. And of course, we've done some examples like that. And once you can calculate the magnetic flux, then you can use L is equal to N times the magnetic flux divided by the current to calculate the self-inductance. That's another capstone problem. Again, if we have covered that chapter, I don't think we've covered that chapter by this midterm, but next on the final, you'll have to be able to do something like that. So those are two capstone problems. Another capstone problem is solving, a circuit using Kirchhoff's voltage rule and Kirchhoff's junction rules, be able to solve a circuit with at least three currents in it. So you got to be able to do the math to solve the system of three equations, three unknowns, or four equations, four unknowns. That's another sort of holy grail / capstone problem that you got to be able to do. I think that's pretty much the major ones. So normally what happens on the final is I'll have like 25, 20 questions or something like that. So I don't have to count each one so big. Like if I only had 4 questions, each one would be like, 25 points each. And then if you miss one, you're down to a 75. That's miserable. So I try to give you a bunch of really quote unquote easy ones, like how many electrons are passing the 1 point in a wire per second if the wire is carrying such and such an amp. That's an easy problem. Or what's the equivalent capacitance of this collection of capacitors? Or what's the equivalent resistance of this collection of resistances or resistors? Those are like little chucker questions. What's the force on this current carrying wire at 60 degrees from the magnetic field, blah, blah, blah. Those things are real easy, but we'll have 3 or 4 questions that are worth a lot more. And they'll be of those varieties probably that I just mentioned to you. And what'll happen is I'll take one that's probably just a regular multiple choice question. I'll put a bunch of paragraphs in it and say, okay, instead of just calculating what the capacitance is and giving me an answer, I want you to derive the electric field due to this charge distribution on a piece of paper, then calculate the voltage difference between this and this, and then calculate the capacitance. And within 15 minutes of completing your midterm, take a photograph of it and email your work to me on that problem. So if you get like the problem exactly right, the multiple choice part, but you don't turn in any work, or your work is sort of made up or magical, then if that question was worth say 10 points, you might get 1 for getting it right and minus 8 or 9 for not having to work. So just be prepared for that type of thing to happen in the midterm. That does happen. And it's usually one of those 3 varieties. You might have to do a cross product, QV cross B. That's supposed to be fairly easy, even though it's normally worth more than a couple points because you're actually putting a vector in a matrix and putting IJ and K in the top row and putting another vector in the third row and actually doing the cross product. Which is a determinant of that 3x3 matrix, that kind of stuff. So some of those questions are just everyday kind of physics questions that you got to do. There might be one where you can't find out what the capacitance of a capacitor is after you've put a dielectric in there, like that next to the last example on the capacitance chapter. So all those type things are in there, but that's really what the final's about. It's some of the problems that are a little more rigorous. I want a couple of those just to, make sure everybody's up to speed at doing a calculus-based physics course. And then the rest of them are, sort of the chucker questions. A lot of the examples the book works. The book works actually some good hard examples, but I've done some harder ones for you guys. I've done ones where they had a current density that wasn't constant, or I had a charge density that wasn't a constant. For instance, I had a charge density rho that's proportional to R, rho that's proportional to R squared, and then calculate the electric field inside and outside, or if it's a current, calculate the magnetic field inside and outside, that sort of thing. So those are all things you should be able to do. So with that in mind, does anybody have any specific questions about anything? Like I said, I will be here again at 5:20 on Tuesday. I'll wait for, like I said, the first 5 or 10 minutes. And if nobody shows up, then I'll just assume nobody's coming, but I'll at least show up in case anybody wants to ask any questions. I'm available on the weekend. You guys can text me. I'm actually going to be out at a physics symposium type thing and be camping during the night. So the internet won't be that great, but I will have access to my text messages, and occasionally I'll be able to check my email. Anybody have any questions now? All right, well, you guys are completely free to go if you don't have any specific questions. I wasn't going to cover new material today. Just I wanted to save this time for you to ask me questions. So anything, if you've got any old practice tests or any old practice midterms or something like that, that's got some questions you don't understand, by all means, ask me. Or, if you happen to run into one, now that you've got statics out of the way, if you run into one that you don't understand, feel free to take a screenshot of the question with the answers, because I need to know what answers are available too. And, ask me about it, and I'll see what I can do to help you out with it. So you still have access to me, even though we don't meet again until Tuesday when the final exam occurs after class. But still, I'm going to try to make sure I'm there for you Tuesday at 5:20 and available all weekend like normal. So tomorrow, Saturday, Sunday, and Monday, I'll be available by text messaging and to some extent email, but definitely text messaging. Thanks for coming. Those of you who did come, I'm going to wait for the last person to leave, and then I will leave. How's it going, Nathan? Nope, Nathan's out here. I thought Nathan would stick around. He usually has good questions. Oh, well, have a good one, folks. Good luck.